Hello everyone, my name is Mr. Kugonza. I'm glad to present to you a lesson on current electricity based on the lower secondary school syllabus as prepared by the National Curriculum Development Center of Uganda. But before we go into the detail of electricity, we need to see the uses of electricity in our world today. Over here on your screen, you can see various components that use electricity, starting from cars, motors, refrigerators and ovens, and television sets, loudspeakers, microphones, mobile phones, and etc. So many of those components, even many others that are not even shown on your screen, all use electricity. So without electricity, really our world would not be a nice place to live in. You would probably not be able to listen to me as well. Most of the various components that we shall be dealing with have got symbols. And the symbols are the ones that are used in electrical circuits, as we shall see later on. So on your screen, you can see various symbols for various components that are used in electrical circuits. A resistor, a resistance box, a cell, a filament lamp, a battery, a fuse, and many others. So those are some of the various symbols that we shall be using in electrical circuits. Now, we have an electrical circuit here shown having three components: a switch, a battery, and a bulb. Electrical energy is carried through wires, and it is due to the flow of electrons. And the complete path along which charges flow is what we refer to as an electrical circuit. So when current originates from the battery, from the right hand side, as you can see, the current will originate from that battery and then will flow through the bulb and will cause that bulb to light. So a current is defined as the rate at which charge flows through an electrical circuit. And the unit of charge is referred to as the coulomb. It is defined as the quantity of electricity that passes any point in a circuit in 1 second when the steady current of 1 ampere is flowing through it. What you see on the screen are three diagrams used to which will help me explain to you what electromotive force and terminal PD are. In the first diagram, we have a voltmeter, an ammeter, a switch and resistor, and a cell, and the switch is open. Now, a voltmeter is always connected in parallel with a component whose potential difference is required. Now, even when that switch is open, the voltmeter will show a reading. So that reading is what we refer to as the electromotive force of the cell. So the electromotive force is defined as the potential difference across the ends of a battery when it is not producing a current. So in diagram 1, the battery is not producing a current because the switch is open. Even in diagram 2, it is again not producing a current because the switch is again open. So if the switch were to be closed, the voltmeter would be reading what is known as potential difference across the resistor. In diagram 3, we see the switch closed now, and there is a current flowing in that circuit. So the reading of the voltmeter is now less than what it was in the first diagram. So this time, the reading is referred to as the terminal PD. So terminal PD is the potential difference across the terminals of a cell that is producing current. The ammeter is a device that is used to register current flowing through, or to measure the amount of current that is flowing in a circuit. So we have two measuring devices here. We have an ammeter and we also have a voltmeter. Voltmeters are always connected in parallel with the components whose potential difference is required, while ammeters are connected in series. with those components through which a current is flowing. In any electrical circuit, there are basically 4 things that you can measure. One, you can measure current. That is one of the measurable quantities, and current is measured in a unit referred to as the ampere, and the symbol for electric current for ampere is A, capital A. Electromotive force that I have just defined is measured in volts, just as the potential difference. They are both measured in the same unit and both have the same symbol. Resistance is measured in ohms, and the symbol for ohms is letter omega. It's a Greek letter, omega. Now, what is electric potential difference? In order to understand electric potential difference, let us look at gravitational potential. If on the right hand side we have waterfalls, and the water is falling from a position of high gravitational potential to an area of lower gravitational potential. So the position which is at a higher gravitational potential has higher potential energy. Therefore, water will flow from the region from a point of high potential energy to a point of lower potential energy. It is not possible for the water to move in the reverse direction. In the same way, electricity flows from a point of high electric potential to a point of lower electric potential. Whenever current is flowing, the point that it flows to is of lower electric potential. So we say that there is a potential difference that exists between any 2 points along a wire if current flows through it. And the potential difference between those 2 points is the work done when 1 coulomb of charge moves from one point to another. The unit of potential difference is the volt, and the volt is defined as the potential difference between 2 points if 1 joule of work is done in moving 1 coulomb of charge from one point to another. Thank you very much for listening to me. I hope to continue giving you more knowledge on current electricity.